Okay, so in this lesson, we're going to learn about surface area of objects, and they are going to be put together, and they're only going to be made of rectangular prisms. So what I did was, the very first thing was we just kind of went over surface area, and surface area is if I take an object and I dip it in paint, how much of the area would be covered in paint? Just a reminder that the area of a rectangle or a square, we can use area is equal to base times height, or we can use area is equal to length times width. It all depends on your teacher, what they use. And again, we never use the multiplication sign anymore, so LW is length times width. So I'll probably be changing back and forth in between the two formulas. Rectangular prisms, just to make sure it is a polyhedron. It has two parallels, so it sits on a base. Well, in this case, it's sitting on the base, and then all the sides are parallel to each other. Anything that has sides that come to a point, that's called a pyramid. Okay, so we have to make sure that the sides are parallel to each other, and it sits on a base, and the base is what gives it its name. So in this situation, since the base is a rectangle, we call it a rectangular prism. So I'm not going to go through these examples. This is all review of grade 8 math. When I was doing it in class, people didn't seem like they were having that big of a deal. There was a formula that you did, or some of you guys learned, where it was surface area is equal to 2 times length times width times 2 times width times height times 2 times, plus 2 times length times height. And it was, that's a great formula to use. I personally like using a chart. So I'm going to use a chart for this unit, but I'm not going to do these examples here just because it didn't seem like there was a big issue in class. However, we did do a math lab, and so what I had students doing was linking 5 cubes together and creating different shapes and counting the surface area. And one thing that we noticed from this lab was that there were areas of overlap, and that brings us to the class notes. So all I wanted the students to learn was that when I put shapes together, we had to take away, there were some areas of overlap that would not get covered in paint because they were put together. So what I'm going to do is I'm going to get to this point here. Composite objects is made from 2 or more objects. So I have 2 rectangular prisms here. Notice the smaller rectangular prism and the larger, and when I put them together in any way, and in this situation, this object down here, I put it together like this little red box is the area of overlap. So if I stick these two objects together and if I dip it in paint, that little red rectangle would never be covered in paint because it's stuck. It's the area that's stuck together, like the two objects are stuck together. We're going to call that overlap. Okay, so overlap is never considered as part of the surface area. So the formula for the surface area of a composite object is, we're going to find the surface area of, let me see if I can change my little cursor here. We're going to find the surface area of the smaller prism. We're going to find the area of the larger prism. And then we're going to take away 2 of the areas of overlap. So we're going to take the entire surface area. We're going to consider it just as a prism. We're going to take the entire surface area of the second prism, and then we're going to subtract 2 areas of the overlap. Now, the reason why we take away 2 of them is because we have to take one area on this side, but then there's also the same area that would be taken away on the larger prism as well. So we have to subtract 2 of the areas of overlap. So we're going to do a couple examples here, 2 examples. Now notice that in my little workbook that I provide to you guys, my charts are going to not match your charts. So I'm going to try and remember to the best of my ability what we did in class, but just in case, just kind of follow along as best as you can. So I'm going to say that this is prism 1 and this is prism 2. Just so that we don't confuse, I put a circle around the numbers so that I know I'm just labeling the prism and it's not a dimension. So that's why I'm circling those numbers. So I have prism 1, and I'm going to find the area of the top and bottom, the left, the right, and the front and the back. Okay? I hope that's the order that I have on your chart, but I'm just going to do them in this. You can follow along and just fill in as I'm going to do it in this order, okay? So the top and the bottom. So let's look at prism 1. Let's look at, if you want to draw a diagram, that's great with the dimensions. I'm just going to write the dimensions in. So I'm going to look at the top, and I see that it's 4 by some number that I don't know. So I know that this and this are the same length, which is the same length as that, which is the same length as this. So this top here is actually going to be a 4 by a 5 meter rectangle. So if I want to find the area of the top and the bottom, I'm going to go 4 times 5. And since I have a top and a bottom, I'm going to times it by 2, and I'm going to get 40 meters squared. Okay? Now let's take a look at the left. So here's my left, or sorry, here's my right. So I take a look at this rectangle here, and I have 4, and again by 5. So my diagram, if I was to draw a rectangle, it would have dimensions of 4 by 5. So I'm going to find the surface area, 4 times 5, and I'm going to times it by 2 because I have a left and a right, and I'm going to get the exact same surface area. Now I have a front and a back. So I'm going to take a look. Here this is 4 meters because it's the same as this. And this is 4 meters because it's the same as this. They're congruent. So if I was to draw a rectangle, or what it would look like, the face, it would be a rectangle that has dimensions 4 by 4. So let's go 4 by 4 times 2. And I'm going to get 16 times 2, which is 32 meters squared. So if I want to find the total surface area of this, I go 40 plus 40, which is 80, plus 32, which is 112 meters squared. So I'm going to put it as surface area of 1. Surface area prism 1. That's what the little subscript means. I'm going to go do that now for prism 2. Okay? So this is, by doing a chart, I'm keeping myself extremely organized. If you do a chart and you show all of your work, it allows me as a teacher to give you the most possible part marks in case your final answer is incorrect. So please, please do your charts, show your work, and allow me the opportunity to give you the most marks as possible. Okay? So let's talk about the top and the bottom of prism 2. So I have a top, which is 8 meters because it's the same as this. So this here is 8 meters, and then I have by 5. So I have 8 by 5. Since I have a top, oh, I'm doing the front. My apologies. Oh, no, no, no. Ay, ay, ay. Top and bottom, this is 8, this is 5. Sorry, I was right. Wrong rectangle, right dimensions. So 8 by 5 is my top, and since I have 2 of them, I have to times it by 2. So I have 80 meters. 8 times 5 is 40, times 2 is 80 meters squared. My left and my right looks like it's a 4 by 5. Those are dimensions. So I'm going to go 4 times 5 times 2, and I have 40 meters squared. Okay, 4 times 5 is 20, times 2 is 40. And then let's talk about the front and the back. Sorry about that. So I have 8 by 4. That's my front. Be 8 by 4 because this dimension and that dimension are the same. So 8 by 4. So I go 8 times 4, which is 32, times 2, which is 64 meters squared. So now if I add those together, I have 8, 80 plus 40, which is 120, and 64, which will give me surface area of prism 2, that's what the little 2e down there means, little subscript, is 184 meters squared. I'm just going to double check that. 80, 40, 120, yes. Okay, so now we have to talk about the area of overlap. So the area of overlap, I'm going to put it in red, is this area right here. So if I was to take this figure and dip it in paint, this is the area that will not be covered, both on Prism 1 and on Prism 2. So let's just talk about the area of overlap first. So the area of overlap is the bottom of Prism 1. So I can actually go here and go to Prism 1 and go top and bottom, and notice that my diagram is 4 by 5. So my area of my overlap is 4 by 5, which is 20 meters squared. Okay, so now I'm going to take all of these numbers and I'm going to put it in my formula. So I hope I remember all of them, 112, 184, and 20. So surface area of Prism 1 is 112 meters squared. I'm going to add my area of Prism 2, which was 184 meters squared. And I'm going to subtract 2 of the area of overlap, which was 20 meters squared. Okay, so I'm just going to double check my numbers. 112, 184, and 20. I'm taking away 2 because I'm going to take away one area from the Prism 1 and then the same area for Prism 2, and that's why I have to multiply it by 2. So surface area is equal to, and I don't know, it's Sunday morning, I'm just going to use my calculator here. So 112 plus 184 equals 296 meters squared. And I'm going to take away 2 times 20, which is 40 meters squared. So I have a surface area, total surface area of the composite object now, of 256 meters squared. Okay. So if you keep yourself nice and organized, double check. Like this is very, very easy for me to go back and double check all of the work if you create your charts. Let's go over one more example. In this case, yeah, that's it. So we're going to go over one more example. A little bit bigger numbers. We have 3 objects here that are put together. We have 2 areas of overlap, so that's my 1 and my 2 I have in red. So let's label this as Prism 1. This is Prism 2. Again, just make sure that you put them in circles so that you can identify that it's not a dimension. And let's go top, bottom, left, right, and front, back. Okay, I'm going to do that for this one as well. Left, right, and front, back. Okay. So there's going to be a lot of flipping back and forth here just because I can't put everything on one page. But let's talk about Prism 1. And the top is 20 by 50 because 50 is the same up here. So I'm going to have 20 by 50. That's going to be my rectangle. So let's go 20 times 50 times 2. And I'm going to get 20 times 50, which is 1,000 times 2 is 2,000 meters squared. Is it meters? Yeah, meters squared. I better put 2,000 in there. Okay. Now, what are the dimensions for left and right? Well, let's take a look. Let's go over here because this looks pretty ugly over here. So my left over here is 20 by 35. So that's going to be the dimensions of my left and my right. So again, I go 20 by 35 by 2 because I have both my left and right. Again, I find my total surface area first and then I deal with my areas of overlap. So 20 times 35 is 700 and then times 2 would be 1,400 meters squared. I wonder if I can do this typing. Let's see if I can do this typing. Okay. So my front and my back has areas of 35 meters by 50 meters. Maybe that might be a little bit easier to do. So I'm going to go 35 times 50, and I'm going to times it by 2, and that's going to give me an area of, let me double check that one, 35 times 50 gives me 1750 times 2, which is 3,500, and meters squared. Actually, I like the typing better. So now if I add all of these together, I get 3,500 plus 1,400 plus 2,000. And I get an answer of 6,900 meters squared. And I always have to go click back there. There. So let's try type these in. Maybe that might be better. So let's go to figure 2. If you want to try these, just pause the video, try it, and then come back and press the video, like to press play on the video, and then see if your answer is correct. So the area of the top and the bottom, or the dimensions of your top and the bottom for Prism 2 is 10 by 30. So 10 meters by 30 meters. So that will give me 10 times 30, and again times 2, because I have 2 of them. So that is 600 meters squared. Okay. So now we have left and right. So my left for Prism 2 is 10 by 20. So 10 meters by 20 meters. So now your area would be 10 times 20, and again we have to times it by 2. So we have 10 times 20 is 200, so 400 meters squared. Okay, so far so good. My front and my back, so 20 meters by 30 meters is your dimensions. That would be your diagram. So you go 20 times 30 times 2, and you get an area of 20 times 30 is 600, so 1,200 meters. Oops, forgot a 0. Meters squared. Okay, so your total surface area would be 600 plus 400, which is 1,000, plus 1,200, so you should get 2,200 meters squared. With me so far? Hope so. Hope I didn't make any mistakes. Please let me know if I made any mistakes. Very, very easy to make mistakes in this. So I'm going to just transfer these two numbers over to my next slide. So 6,900. Oh, maybe I can copy and paste this. Let's see. So Prism 1. So 6,900. I'll add in my plus signs. Okay. And Prism 2, 2,200. Let's put in my plus. Okay, so far we're just doing our total surface area. That's Prism 1, this is Prism 2. Let's do Prism 3. And again, sorry, I'm going to have to flip back and forth. So left, right, top, bottom, left, right, front, back. So let's talk about the top and the bottom of Prism 3. So the top has dimensions of 40 by 5. So 40 by 5. So 40 meters by 5 meters. And so you got 40 times 5, which is 2. Holy cow. 200 times 2, which is 400 meters squared. Okay. Sounds good. Why don't you try left and right and see. Okay, so the left and right. So I can see the right a little bit more clear. So I'm going to go 50 by 10. So 50, I'm going to bring that down a little bit. 50 meters by, was it 50? I think it was 5. Sorry, my apologies. By 10 meters. I've already calculated the area there. So 5 times 10 times 2, 50 times 2 is 100 meters squared. I'm just going to double check that because I got distracted. Yeah, okay. So 5 by 10, 5 by 10. So let's talk about our front and our back. So our front is 40 by 10. So 40 meters by 10 meters. So 40 by 10 times 2 is equal to 800 meters squared. I always put my meters squared in just so I don't forget. So let's add up our surface areas. 400 plus 100 is 500 plus 800 is 1300 meters squared. Now it might be a really good idea just to go back and, you know, like as you were doing it, make sure you do all your calculations, like double check your calculations, because most of the times when I mark, I'm finding that it is more of a calculation, like you didn't add properly, you didn't multiply properly. You got the grade 9 stuff, it was the grade 2 stuff that was getting you guys. So just go back and just double check all of your calculations before, you know, going on to your next step. These little 1s and 2s, I put them in red because we actually have 2 areas of overlap. So I'm going to deal with the first area of overlap. The first area of overlap is the left face of prism 2. So let's go to the left face of prism 2. And we have 100 meters by, 10 meters by 20 meters. So that is actually my area for overlap 1, 200 meters squared. Let's go and look at our area for overlap 2. It is actually the left side of prism 3. So let's go to the left side of prism 3, and I'm just going to copy and paste it over. Okay, so the left side of prism 3, and I get 50 meters squared. Okay, so I'm going to finish up. I never did finish. You know, just putting in my things, So I have to add up all my surface areas. I have to add up 6,900, 2,200, and my 1,300. Okay, so I'm going to do that. Actually, no, let me finish my formula first. I'm going to take away 2 areas of overlap for my first area, and I'm going to take away 2 areas of overlap for my second one. Okay, and I'm going to go back to the diagram. I have to take away 2 because for overlap 1 because this area appears both on prism 2, and this area will be taken away also for prism 1. This area of overlap here appears on prism 3 and the same area on the right hand side of prism 2. That's why we always have to take away 2 of them. Okay, so let's go and now let's calculate, and I'm definitely going to use my calculator for this one. So I'm going to add up my first. So I'm going to add up 6,900 plus 2,200 plus 1,300. And I'm going to get 10,400 meters squared just for adding up all the surface areas. I'm going to subtract 400 meters squared, so that twice that first area. And I'm going to subtract 100 meters squared for the second area of overlap. I'm just timesing by 2. So I get 9,900 meters squared as my total surface area. Now once again, if I was to take this entire figure, dip it in paint, and then bring it out, I would cover 9,900 meters squared. So that's what we've done. We've talked about composite objects that are made up of two or more objects. In this lesson, we only did rectangular prisms. The easiest way to do this is not necessarily doing it by a formula where you have 2LW plus 2LH plus 2WH. I create a chart, and then it's a little bit easier to deal with the surface area, taking the surface area prism 1, the surface area prism 2, and then subtracting that all important twice the area of overlap. It appears on both prisms, so therefore you have to take away 2 of them. So now don't you know that I don't ask a lot in terms, I'm very specific with the questions I ask you. 4F, really important. 8B and 10. 10 is a tough one. And then 16 on page 32 if you are going for that honors mark.